Alright, recall from class we were working on finding the equation of the line that passes through these two particular points. There's no real context here, but we understand that we can see what's happening with the line is it's a decreasing line, so we should have a negative slope, and we can see that the y-intercept, if we look carefully, has to be somewhere between 6 and 7. But maybe it is 7, maybe it's not, it depends on how poorly drawn this line is. Nonetheless, that's my task. Now the first thing I need to do is figure out what kind of rate of change I have here so that I can walk back to the y-intercept. So I find the change in y over change in x. Before I do any calculations, I look at the graph and I observe that to get from this point to that point we have to go 8 horizontally. That's 7 this way and 1 that way, 8 total. And to get vertically between those 2 points we have to go 8 1/4 plus another 4 more for a down 12 1/4. So just to see that my math is right, I tried using the calculations method. So when we subtract two things, we find their distance. So 8 1/4 minus a negative 4 is going to give me 12 1/4. So that's why I add a negative. And negative 1 minus 7 gives us negative 8. Then we can reduce this fraction by multiplying top and bottom by 4. Which is one of the worst slopes I've ever seen. Negative 1 in 17/32. Not a good slope. However, it is about negative 1.5 or so, which is consistent with what I see when I look at this line. It's steeper than negative 1, so this is consistent. If that's true, then all I have to do to find my y-intercept, since this puts negative 1, 8 1/4, I just have to go over 1, down 1 in 17/32. So the problem really just breaks down into subtracting 8 1/4 minus 1 in 17/32. Easier said than done, of course. First I find a common denominator, and now I'm worried because I'm going to have to subtract 17 from 8, which will make it negative, and now I'm all confused. So I'm going to borrow from one of these whole numbers and add 32 over 32, so I can have 7 and 40/32 minus 1 and 17/32. Now, 7 minus 1 is 6, and 40 minus 17 is 23, and that's the y-intercept. See the y-intercept very close to 7, and when you look at the graph, the y-intercept is very close to 7. Looking good. Now that's the y-intercept, and that is the slope, so I can put it in the slope-intercept form. Start at 6 and 30 and then go down 17/32, 1 and 17/32 for every x. I was pretty unsure whether or not this was going to work, so what I did was I put in 7 for x, and wanted to see if I get negative 4. It took a little bit of number crunching, but I eventually found out that y does in fact equal 4. So this is the equation of the line that happens to go through those 2 points. Now the reason I chose this particular problem to look at is because it's not particularly nice. It's not a nice process to have to do all this busy work here. So what I'd like to do is maybe figure out if there's another way to do this. So that'll be in the second video, which will be coming in just a moment.